Hello, students. We're working today on Notes 13, where we're going to be solving quadratic equations by graphing. So in the last lesson, we learned to graph quadratic functions. And in this lesson, we're going to use a little bit more of the technology, using Desmos a little bit more, to graph our functions. And we're going to concentrate on two other important points on the parabola. And I say two, sometimes there are actually less than two. So let's talk about what is happening here. We're going to be looking for the solutions to a quadratic equation by finding the x values of the x-intercepts of the graph. So we're going to look at 4 different types of parabolas, and they will show you that sometimes you can have 2 x-intercepts, which would be 2 solutions, or you could have 1 x-intercept, which would be 1 solution, or in fact, you could have no x-intercepts and no real solution to the quadratic equation that would go with this graph. So right now we're just going to take a look at graphs that I've already provided for you. And notice I didn't give you the equation, just the graph. So the part that we're going to be looking at is where the graph crosses the x-axis. So this is your x-axis, and this is your y-axis. So we're looking at where the graph crosses the x-axis. So 1 point would be here, and this is the ordered pair of -3, 0. And then the other x-intercept, where it crosses the x-axis, would be at +2, 0. Notice that the y value is going to be a 0. So then we're asked to find the solutions of an equation that would give us this graph. The solutions are the x's out of the x-intercept. So we're going to write those in a solution set, and the order that we write these in does not matter. So I could write the -3 first and then the 2, or I could write the 2 first and then the -3. So these would be the solutions to an equation that would go with this parabola graph. On your second example, so again, I want you to find the x-axis. So this would be the x-axis, and this would be the y-axis. So you have the graph crossing, or actually this time just touching, the x-axis at this ordered pair. And so this ordered pair is 5, 0. Notice that in this graph, the 5, 0 is not only the x-intercept, it's also the vertex. And so this 1 point is actually serving 2 functions, and that's a good way for us to remember that this is called a double root. And root is another word for solution. So we have the x-intercept of 5, 0. And so if we did see an equation that would go with this, we would find that the equation just has the 1 solution because it's the x out of the x-intercept. So just 5. And then we'll look at example 3. On example number 3, we'll locate the x-axis, which is right here, and the y-axis right here. And we're looking for where this graph crosses the x-axis. Well, it does not, and it never will. These two ends are continuing up. This is a minimum point for the vertex. So there are no x-intercepts, so we'll write the word none here. But when we get to the solutions, we're going to add a word to this. Instead of saying no solution, we're going to say that it has no real solution. For those of you that go on and take Algebra 2, you will find that there are solutions. I'm going to try to write that a little bit better. There are solutions that are called imaginary solutions. And again, you'll learn more about that in Algebra 2. So that's why we want to just make sure that you know it does not have any real solutions when there are no x-intercepts. And then I just went ahead and put a fourth example back in here so that you could see one that has two solutions again. This is your x-axis and y-axis. So we've got an ordered pair of -2, 0. And another ordered pair. Again, these are both x-intercepts. Now this one is right in the intersection of the x and y axis, and that would be 0, 0. So 2 x-intercepts, 2 solutions. So the solutions would be the -2 and the 0. And again, those are the x values out of the x-intercepts. So we're going to take a look on the back side at some equations that you will graph and then fill in some extra information. Now, for your notes, your equation is y equals x squared minus 2x minus 3. I included the graph in your notes, but when you get ready to do your homework, the graph will not be there. What you will do is take your equation and type it into Desmos. So I'm going to demonstrate that on this video. So I have y equals x to the second minus 2x minus 3. So I'm going to go to Desmos, to the graphing calculator, y equals x squared minus 2x minus 3. And if you need to know the vertex, you can click on that point. As long as you have a good view of the parabola where you can see where it makes that either lowest value or highest value, you should be able to click on the vertex and the various other points that we're going to be asking for. So I'll just show you how clicking on them will make this show up. So notice that I have my 2 x-intercepts, I have a y-intercept showing up, and I have my vertex showing. So now I'm going to go back to the notes page because that's the picture that I copy and pasted for you on these notes. So this is what you would be looking at on Desmos after typing in this equation. So when it asks you about the vertex, for that, I want the ordered pair. So parentheses, the vertex is, in this problem, this minimum value. So 1, comma, -4. The vertex needs to be written as an ordered pair. Then the axis of symmetry. Now, you won't be drawing this in because you're not drawing the graphs this time, but you should know the equation. It is always x equals, you must have that, and it's the x out of the vertex. So in this case, x equals 1. You must have it as x equals. All right, then we'll look to see, do we have a lowest point or a highest point. We have a low point on here, and so this would be a minimum. You are to circle that, and then the minimum is the y value out of your vertex. So out of your vertex, it's the y value of -4. If you want, you can put -4, but, or excuse me, you can put y equals -4, but if you just put the number, that will be fine for the minimum. So those three are related to each other. They're all related to the vertex. Then you're to give the y-intercept. Now, let's label again. This is the y-axis. This is the x-axis. You'll see that, again, you're not graphing these, so you'll have to find this point from Desmos. And so a y-intercept is an ordered pair. 0 is in the place of the x, and then whatever we get for y, which in this one is -3. So there's what the y-intercept is. And then finally, we'll do the x-intercepts. This one has 2 x-intercepts. We found these on Desmos. So the ordered pairs for the x-intercepts would be -1, 0, and the other one over here at 3, 0. Make sure you write those as ordered pairs. And then I wanted you to notice that we have this equation of x to the second minus 2x minus 3 equals 0. Well, that is this equation, except instead of y equals, we have 0 equals. When we set this equation equal to 0, we could factor it. We do know how to split the middle and factor it. But in doing so, we would find that the solutions are already showing to us on this graph. The solutions are, remember what we said, the x values of the x-intercepts. So we would get -1 and 3 for our solutions to this equation, which is the same as what we typed into Desmos, only equal to 0. So sometimes you'll hear these called the zeros of the function, and that's because the equation would have to be equal to 0. All right, so that's what we're going to be working with. We're going to take a look at a second problem. So you have y equals -x to the second minus 5. The first thing you would do is do the graph, because those on your homework will not be provided. So y equals -x to the second power minus 5. And so sometimes you can't quite see all the graph. You can always zoom in order to see more of it. Notice that you have your x-axis and your y-axis, and there's only one point showing up. So we'll go back to your notes. I just copy and pasted that graph for you. And so the vertex is this point that we have showing of 0, -5. Write it as an ordered pair. Then the axis of symmetry is x equals, and it will be the x out of the vertex, so 0. This one has a highest point, so we'll circle that it has a maximum, and it's the y value from our vertex, and so that would be -5. All right, then we're going to look for the y-intercept, and the y-intercept happens to be, so here's the y-axis. Well, that y-intercept happens to also be the vertex. So the y-intercept is also 0, -5, written as an ordered pair. And then we're going to look for the X-intercepts. This is where the graph would cross the x-axis. Well, it doesn't. These are going to continue down, and so they're not going to come back and cross the x-axis. And so this has none, no X-intercepts. And then remember that we want to say that the equation would then have no real solution. So this negative x squared minus 5 equaling 0 is the same. So these are the same equation, but when we talk about solutions, we have to have it equal to 0. And basically what would happen on this is that if you tried to add 5 to both sides and then divide by -1, if you were trying to solve it with algebra, you would get an x squared equaling a negative. And taking something times itself can never give you a negative with real numbers. So that's why we say it has no real solution. So again, you'll be doing homework where some of the graphs will be provided and you just have to look for the x-intercepts and then the solutions, and some where the graph will have to be done on Desmos, and then you will come back to your paper and fill in the table. So good luck on your homework. This will be another assignment that is a worksheet.